So if we go back to Canvas, you can see that this is going to be in week 12. And this is where you would find it, the experiment in um, Canvas under the module. So there are these right here that's highlighted in green are available. The first one is just a title, but this second one here gives you the experiment as written in your lab manual. What you want to do is to access the lab archives to upload your intro. You guys probably have done that. Remember, this experiment's not due till Friday. You go all the way to the bottom, you click on here, and then it'll take you to lab archives where you can complete the intro part. Okay. So because I've linked lab archives to Canvas, the only way you get into lab archives is through Canvas. I don't know why they do that, but that's just the way lab archives have decided to bridge the gap between Canvas and lab archives. Anyway, let me go ahead, and that's the first link that you will see in this module. The second one is really where you're going to find the bulk of your information. That would be the determination of the molar mass of an unknown, data and observation. That's where you'll see the movies. Okay, so we have the PowerPoint, the experiment, that method 1, method 2, and the Excel spreadsheet. Make sure you guys stick around because you guys are going to be assigned an unknown, and I'll show you how to get that data when I talk to you guys through the PowerPoint. So this PowerPoint that you have is actually a movie, but it's basically a movie of my PowerPoint slide. So let me move to that and share that particular screen. Here we are. Okay, so this is the that multimedia that you found in Canvas. It's the it would normally be the PowerPoint I give you guys before the lab, but in this particular case, I've modified it because now it's online. So it gives you some background information. That is, what we're going to do is we're going to use titration techniques to determine both the molar mass and the pKa, or the Ka of an unknown, and thereby, with that information, identify the unknown from a list. It tells you about an acid reaction, tells you about the mass action expression, tells you that if you write the mass action expression and you see that you get to a point where the concentration of the acid and its conjugates are equal, and then the pH is equal to the pKa. And you guys already know that because we did that in experiment number 4, where when you reach the equivalent point, if you look back in your titration curve and you found the volume at halfway to the equivalence point, then that pH equals the pKa. Here, it gives you the ice table for that particular calculation, and it again shows you how the chemistry works out. And then here it kind of tells you how to read your titration curves so that you get pertinent information. So let me just comment on this. You guys will get a titration curve because you guys are titrating. You guys are titrating an weak acid with sodium hydroxide. So the titration curve that you guys are going to generate is like this. The important information that you want is the equivalent volume and halfway to the equivalent volume. The equivalent volume right here is going to be able to tell you the molar mass of your unknown. Okay, and that's because the moles of the hydroxide, your base, is equal to the moles of your acid. Even if that acid is a weak acid, that's still true at the equivalence point. And then halfway to the equivalence point, it's going to provide you the pKa of your unknown acid. That's why those two informations are important in this particular experiment. Okay, so again, the calculation, there's two methods, method one and method two. Method one is a straight titration. Method two is titration to the end point and then adding an equal volume of acid back to that neutral solution. So this is just a pre-lab discussion for all of that. Okay, here is actually the calculation for your molar mass. And if you know the concentration of your base, your sodium hydroxide, then if you have the molarity times the volume, and the volume is how much sodium hydroxide you add to reach the equivalent point, then that is the moles of your hydroxide. And because you're at the equivalence point, then that's also the moles of your acid. So if you know the moles of your hydroxide, that equals the moles of your acid. Remember that molecular weight, molar mass of a chemical is grams per mole. Well, the moles of the acid is just that. How do we get the grams? Well, that's the mass of the acid that is analyzed. So if you got your mass of your acid, and I give you that information, and you divide by the moles of the base, moles of the acid, and how you get the moles of the acid? It's based on the equivalent point data. That is your molecular weight. Okay. So you can see the calculation is pretty straightforward, but you got to make sure that you know where to find that data. That red is really bright. Let me change to that. Anyway, that's this calculation right here. Okay, that's this calculation. The mass of the acid and then the moles of the base, which is equal to the moles of the acid, is just the molarity of the titrant times the volume of the titrant at the end point. So this right here is the list of possible unknowns. Make sure you use this updated list rather than what's found in your lab manual, because we have to include other acids and throw out other acids that's in the lab manual. So this is the up-to-date list. Okay, that's the up-to-date list. And what I have done is I've gone ahead and taken lactic acid and do that experiment for you. So lactic acid is not one of the unknowns that you guys are going to be given. This is the illustration of the equipment that you guys would be using. This is basically the setup, and the setup is exactly the same as experiment 4, except now you're analyzing your unknown. What you do for, this is method 1 now. Okay, this is method 1. You're doing 3 trials. So what you need to do is you take your unknown and you weigh it, and you determine a mass so that when you titrate that acid, you're using less than 50 milliliters. Okay, so that's going to be provided for you. Then you add water, and the reason why you can add water is because the moles of the acid is fixed based on the mass. The mass of that acid is going to determine the moles of that acid that you have. The amount of water you add does nothing to the moles of the acid. All you're adding is H2O. Yes, the concentration changes, but remember, it's the moles of the acid that is critical. Adding water does not change the moles of the acid. That's why when you're doing titration and you see someone just squirting water to the side and to the tip of the beaker, it's okay, because that's not changing the moles of the acid, of the analate that's in there. And that's what's critical in the titration. So we add water to it, and then once we have water, we put indicator. You don't have to put indicator in part 1, but I may have in my movie, and then you titrate it past the endpoint. Okay, so here it is right here. You titrate it past the endpoint, and then when you're done, you do the 2 other trial. Once you have the data, then you can export that to Excel, and then you can do a first derivative and second derivative. And that's why that's important, is because then you can, let's see if I have that. You can determine the equivalent volume, which is critical if you want to determine the molar mass. Remember, the molar mass is determined based on the moles of the hydroxide. The moles of the hydroxide is equal to the volume that you've added. That's the equivalent volume times the concentration of the hydroxide. This is part 2. In this particular part, what you guys are going to be doing is you're going to take your unknown acid and you're going to weigh back in method 1 right here. Okay, right here in method 1, you weighed a certain amount of mass so that you can titrate it to less than 50 milliliters. Here in method 2, what you've got to do is you've got to weigh a mass that is 5 times greater than what you weighed in method 1. Why? Because what you guys are going to do is you're going to take that total mass, put it in a 250 ml beaker, and then just use 25 milliliters of that solution. So it's like taking 1/10 that concentration, or 1/10 that amount, because you're not titrating the entire 250 milliliters of acid. You're only titrating 25 mils of it, and 25 mils is 1/10. That's why your dilution factor is 10. So you have to adjust your calculation for that dilution factor, because again, you're only taking 25 mils and analyzing that. So this is basically the step. You weigh an amount that's 5 times from procedure 1. You dissolve it, make sure everything dissolves. Then you put it in a 250 ml volumetric flask. Then when everything's okay, you draw with a pipette, 25 milliliters. You put it into a beaker or Erlenmeyer flask. You add water again so that everything's sort of mixed, and then you titrate it. But don't forget your indicator. Here you need an indicator because you have to stop at the endpoint. You have to stop the titration. You cannot over titrate in this particular procedure. Okay. Once you've reached, once you've made the solution pink, so you reach the endpoint, what you need to do is you need to go back to your acid. So this is the stock. Draw an additional 25 mils of acid, and then add that 25 mils to that solution that has just been titrated. What that does is, remember you added acid when you titrated it? All that acid has been converted over to its conjugate when you reach the equivalence point. By introducing another 25 mils of acid back into the solution, you now force the solution to have equal amount of acid and its conjugate, because the 25 mils that you originally put in is now the conjugate base. By introducing a new 25 mils of acid, you have this equal. And if you read the pH at this point, the pH equals the pKa. Okay, that's why it's so critical in this experiment that you stop at the endpoint and don't titrate past the endpoint, because by adding the 25 mils of acid and reading the pH at that point, you have the pKa automatically. So this is again the data. This would be the list of unknowns that is possible. So here's the calculation, and let me run it through. This is the molar mass of, let me blow this up. This is the molar mass of the sodium hydroxide. I already know that I'm doing lactic acid. You guys don't know that. That's ultimately what you guys are calculating. But I just want to show you that my calculation is consistent with what I have. The concentration of your sodium hydroxide is 0.097. So make sure that you have that because you're going to need that in your calculation. I also know lactic acid has a pKa of 3.86. So if you watch the video, what you'll find out is that the initial volume of my titrant is 0.1722. Sorry, that's not the initial volume. That's the mass. That's the mass of my unknown. Okay, that's the mass of the lactic acid. And you notice all three masses are different because I'm doing three independent titration. The equivalent volume that I use in my titration, what you will see in the movie is that it comes out to 19.45. The pKa at the equivalent volume, or the pH, this is not pKa, the pH at the equivalent volume is 10.35. Halfway to the equivalent volume, that's my pKa, that's 3.68. So this right here is the pH at the equivalence point. But if I look at the titration curve, this is halfway to the equivalence point. And you can see that these numbers are pretty close to the theoretical value. Okay, they're pretty close. And I do an average right here. So this value right here is the pH at the equivalence point. So what is the molar mass? The molar mass is 91.27. And how did I calculate that? I took the volume, which is 19.45, times the concentration, 0.097. That's the moles of the base, which is equal to the moles of the acid. So if I take this number and I take this mass, 0.1722, because that's the mass that I'm using, and I divide by this moles right here that I calculated, okay, this number right here, then that ratio comes out to 91.27. That's that. This is the mass of the acid. This is the moles of the base, which is equal to the moles of the acid. The mass over the moles is the molar mass. And you can see that 91.27, 89.95, 90.39, it's pretty close to 90.08. Okay, so let me go ahead and clear that. You guys can watch this video again if you want. It'll be posted. So let's take a look at method 2. That was method 1. That was method 1. Okay, this is method 2. Notice that the mass is all the same, and that's because I took that amount of acid and put it in 250 ml vol flask. Okay, the equivalent volume, the volume I needed of base to reach the endpoint, was 9.04. The pH at the equivalent point, I should correct that, is 6.02. But when I do the analysis, that is, I titrate it to the endpoint and then I put 25 mils back, I get this as my pH reading. Okay, so again, I take the average and I get that. And you can see that that number should be close to that number, which is close to that number. They should agree with each other. Here, what I do is I take the volume of the base and I multiply it by 0.7899 gram. Sorry, let me go back. Yeah, change that and erase that. Okay, I take the volume of the base and then I multiply it by the concentration of the base, which is 0.097. That now is the moles of the base for this titration, the first titration, which is the moles of the acid. What I could do now is take this mass and divide it by 10. And then, because why? Because I only use 25 mils in my analysis. That's 1/10. So if I take that mass and divide it by 10, and then divide by the moles of the acid, then that should give me a molar mass of an acid that's consistent with my previous trial. You got to remember the dilution factor, because if you forget the dilution factor, you're going to be off a considerable amount. So you can see that the analysis here is not so difficult once you understand what's going on. Um, Here are the formulas that I've applied for the cell 10, C10, which is right here, has that formula. So if you guys do enough Excel, you know that in Excel, you always write the formula based on the cell so that people understand what type of calculation you are doing. Anyway, let me go ahead and move on from here, because I want to make sure that. So in the end, um, oh, I forgot to show you one other thing. These right here, and it's found in Canvas, is the data for the unknown. If you're assigned unknown number 10, then this is method A, this is method B. I'm not going to tell you what the unknown is, because that's what you guys are going to be calculating. But I do tell you what the pH at the halfway to the equivalent volume is right here. Okay. These, I should correct that, should say pH at the equivalence point, not pKa. pH at the equivalence point. So that's for unknown number 10. That's for unknown number 20. That's for unknown number 30. That's for unknown number 40. And that's for unknown number 50. So let me just see who's here. Ashley, you are assigned unknown number 10. Crystal, you are assigned unknown number 40. Elijah, you are assigned unknown number 30. Eric, you are assigned unknown number 50. Who else am I missing? Let me see. Check real quick. Oh, Mace, you are assigned number 30. Rachel, you are assigned number 20. And Vanessa, you are assigned number 40. Okay. I don't have Emma here, but if Emma's around, she's unknown number 10. And then Andy is unknown number 20. And who else am I missing? I think that's about it. Okay. That's the unknowns. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, Samantha. She's got unknown number 50. So those are the unknown assignments. And where do you get the data? You get the data here in the Excel spreadsheet. Okay. So this is a summary of the experiment. Clear my notes real quick. Okay. That's a summary of the experiment. The last page is right there. And then, so again, illustration of what's happening. We're doing the titration. We add acid back. We read the pH. That's the pKa. So that's method 2. This is a titration curve that is indicative of what you have. And again, what you want to remember is that the equivalent point, equivalent volume, that's how you get your molar mass. halfway to the equivalent volume. So what you want to do is find 1/2 equivalent volume. That pH is equal to your pKa. So that pretty much is the experiment. Let me change gears and let me give you a preview of the movie. You guys, of course, can watch it at your leisure, but I want to give you a preview of the movie and then just kind of walk you through that particular setup. So I think we are, get to that page right there, then get this out. So under lab archives, we're still in this page right here. Make sure I have that page. That's it right there. Okay, so this first multimedia is the PowerPoint. The second one takes you to my YouTube channel, and then I'll just scrub through here so that you guys can see a fast forward. Remember, this particular analysis is for lactic acid, but it would be very similar for if you guys were doing your unknown. So here, I actually, rather than give you, because I didn't really have time of showing everything, I just did an illustration and show you the steps of what's going on, which is basically a summary of pictures of the Ken Burns effect, that is, of my PowerPoint. And here's the procedure. So let me go ahead and scrub through this because I really want to show you the experiment itself. So here I am calibrating the pH probe. Don't worry about that. Here I am. Remember that you want to write down the observations because that's part of it. Doing the titration, and I'm doing the titration based on volume. I'm not doing time. I'm adding a certain amount of base, and as I add the base, I'm reading the volume in the burette, and then Vernier automatically records the pH. So let me go ahead and go fast forward on this, and then throughout, I don't talk in this video. Throughout, in key points of this video, I show you some important data like the volume at the equivalence point, the pH at the equivalence point, and this right here is the simulation of Logger Pro for that particular analysis. So Logger Pro has a way of recording what was done, and you can just do replay. So that's the data, that's the calculation for this particular lab. So in method one, you just do a straight titration and you analyze the acid based on the titration curve. Let me show you method two. That's this link right here. So let me go ahead and start. I think in this particular experiment, I show you that I weigh a certain amount of acid, and then I put the whole thing in a 250 ml volumetric flask, and then I take 25 mils of that. And so here you can actually see the volumetric flask that I used in this particular experiment. Here it is right here in front. Okay, so here I am adding the 25 mils and then adding water. Again, the amount of water I add does nothing to the moles of the acid. And then I just titrate it until I reach the end point. So you won't see a titration curve here. All you will see is 3 dots. The dots at initial, what the pH is, that's this right here. And then the dot at the equivalence point. Okay, so I titrate it to the equivalence point. And when this thing turns pink, I know I've reached the equivalence point. Okay, so here it is, pH at the equivalence point 6.02. But that pH is not relevant because that really doesn't give me much information. It's when I add the additional 25 mils of acid back. So you can see that the solution is slightly pink. So I know I've reached the equivalence point. I record the volume because that's important. Then I add the 25 mils back into that solution. And this is it right here. What you'll see is I draw 25 mils from my stock solution, and then I add it into my beaker. So see how it turns clear? Because now we are not at the neutral point, we are back at halfway. And what I do is I record the pH, and that's the third dot right here. The third dot that you see right here in um, Logger Pro is the pH at, after I add that 25 mils. And I tell you, pH at halfway is 3.67 for this particular analysis. So you notice that when I do this, this right here is actually the third dot, this right here. You see that it jumped all the way here because I changed it to a volume. So this was the beginning, this was the equivalent, this is halfway to the equivalent. Anyway, that's the rest of the movie, and then these are the data set. So let me go ahead and go back here. So these are the three multimedias. Click on this little icon. You can download this file, of course, but this is the data of what's been collected. This is a list of the unknown. This is the data for the lactic acid, and it shows you the calculation. And then this is the data depending on what unknown you have. Here you can see that the mass of the three trials, they're going to be different. The equivalent volume, this should be the pH at the equivalent volume. This is pKa, or the pH at halfway to the equivalent volume. And then you guys are to calculate the molar mass. Here is method 2. And remember, the mass are equal because you put everything into a 250 ml volumetric flask, and then you only draw 25 mils of that. So the only difference between this calculation and this calculation is that you have to take this mass and divide it by 10. So that's the data for the experiment, depending on which acid you guys are assigned to. That's this right here. Okay, I'll close that. And then remember that in this page, you can go to towards the bottom and then link to lab archives to input in lab archives your data and observations. Once you do that, a week and a half later, remember, this experiment is done by Wednesday. So a week from next Monday, you guys, this experiment will be due. So this is where you click in order to submit your post lab. And then when you submit your post lab, click here, because this is where this will take you to lab archives. And I want basically just a summary. I click on that. You're going to basically tell me what your unknown is, what the molar mass of your unknown, and what the pKa of your unknown. And I'll give you top choice and second choice if things are close. So you can turn in 2 choices of what your unknown is. Your top choice will get full credit if you get it right. Your second choice, you probably get 25% off. Okay, but it's at least better than getting 0 if you guess wrong in your first choice. So that